Kia ora, Year 12 and 13 and Year 11. Here's question 3E from last year's complex numbers paper. Now I'm remaking this video. Those of you who are very quick will already have watched one on this video and be wondering, what is she doing? Well, what I'm doing is that Henry suggested a far faster way to do this question than the way that I did. And the way that I did the first time through was also the way that was done in the schedule. So I want to show you what the question is and then talk about two approaches and why my first way was much more likely to lead to mistakes. So what we've got here is we've got an equation with a whole lot of surd signs, right? And we've got a third thing on the bottom line, so a square root minus a square root and a fraction, and it equals 4. Now, my immediate reaction as soon as I saw this bottom line was to think, oh, I'm going to multiply by the conjugate of those two surds. And this is the way that we do that, right? So if we've got, this is a different example without x and k, but suppose that we start with 2 divided by root 7 plus root 3. Then if we want to do something with that, usually what we do is say, well, if I multiply by root 7 minus root 3, I'm going to simplify the denominator significantly. The difference, though, is that here I don't just have an expression. So let's get rid of this and take a look now at the question. What I've got here is an equation, and Henry pointed out that that meant that there was a far easier way to do this problem. And I reckon it takes about half as long. So what I'm going to do here is do it Henry's way. And you can try it the other way if you want. If you want to do that way, just go look at the schedule. So Henry said, well, why can't we just multiply both sides by the denominator? And that's exactly what I'm going to do. So we get root x plus k plus root x minus k is equal to 4 times root x plus k minus root x minus k. So the next thing to do is to expand and then collect up like terms. So over here I get 4 root x plus k minus 4 root x minus k. Simplifying, I'll get 5 root x minus k is equal to 3 root x plus k. That gives us root x minus k, oops, don't know what's happened there, 3/5 root x plus k. And now I'm ready to square both sides. So here we'll get x minus k is equal to 9/25 of x plus k. Collecting up like terms again, on this side we have 25 minus 9 over 25x equals 9/25 plus 25 over 25k. Okay, so all I'm doing here is I'm adding that onto both sides and I'm taking this off both sides. Simplifying, I get 16 over 25x is equal to 34 over 25k. And that gives me x is equal to 34 over 16k, which is equal to 17 over 8k. So now I'm going to show you the other way that I did it, and I'll see if anyone actually watches to the end. Maybe you will. This is how I did it before. You will see my stupidity. Right, so Henry, nice pickup, well done. Hopefully this way will show you what not to do. But this is a really useful method sometimes, just not in this situation. So here we've got this, and I'm going to multiply the top and bottom by the conjugate surd. And we've got 4 equals that. So we'll just see if we can squeeze that in. There we are. Right, so simplifying, here we get x plus k. This is actually really good practice. So I'm just going to keep going. Now this and this will simplify away. That's the whole reason we do this. So we get minus x minus k here. We have to be a little bit more careful in the numerator. I'm going to have x plus k for those two. And then I'm going to have plus x minus k for these two. And then I get a double. This one times this one, and this one times this one are the same. So it's going to be 2. That's a 2, not a third sign. So 2 root x minus k times x plus k, and that equals 4. So by now, I'm sure you're going, I like the other way so much more. Well, so do I. So there's 2k, and that equals 4. And here I get 2x, the plus k and the minus k go, plus 2 root x squared minus k squared. I can divide everything through by 2 on the left-hand side. So I get x plus root x squared minus k squared is equal to 4k. Right? So the 2's gone everywhere there. Next, we do this. Believe it or not, this is how the schedule did it, and this is how I did it, because my brain was not working. Right, x squared minus k squared is equal to 4k minus x squared. Expanding that, what do we get? Well, we get x squared minus k squared equals 16k squared minus 8kx plus x squared. The x squareds go. Whoop, something weird's happened to the pen. Oh, don't know what happened. Right, well, complete shutdown of OneNote. Wonder if the recording's still going. There we go. Right, where have we got to? We got down to here. What a disaster-filled video. There we are, minus 8kx plus x squared. Now they can go. Something's not right. That should be k squared. So we get negative 17k squared is equal to negative 8kx. X is equal to 17k squared, negative 17k squared over negative 8k, giving me at last x is equal to 17k over 8. So that's our final answer there. Now just compare all of that working to what we did here. Well, actually, you know, doing it the first way still looks like a lot of lines, but each of those lines is a really simple step. Okay, so the moral of the story is always think before you act when you're doing maths, and there's more than one way to solve a problem. Thanks for watching. I'll do some more later, hopefully without mishap.